All right. Hopefully the thing is recording really nice and good for us right now. Okay. We have the Hydrosphere, Chapter 1. We're now into our next unit of Earth systems on here. So let's go ahead and go right in here, make things quick for you guys. Okay. I did start out a couple things on here. This PDF is going to be online, all of Chapter 1, and then later is going to be Chapter 2. So let's go with Chapter 1 on the big question is what is the hydrosphere? Couple things to notice on here as I scroll up and down. There's going to be some stars on a couple places, some things to keep an eye on. Okay, so I'm going to read a little bit on here. I'm going to pause, talk. I'm not going to go too super long. I'm not going to read it word for word on here, but just thinking for a moment before I get going on this chapter is I do have the word hydro and hydrosphere. In Greek and Latin, we did talk about the word hydro meaning water. Even says so right here when we talked about Greek origins. The word part hydro means water. So we're talking about hydro or water sphere. So part of the planet of water. Okay. If you look at Earth from space directly above the center of the Pacific Ocean, you would barely see any land at all. About 7/10 of the Earth's surface is covered by water. Most of the water is found in the oceans. They're pretty big. Water is also found in streams, rivers, ponds, and lakes. Cracks and spaces underground in soil contain water too, and weirdly enough, there's some water in the air. Most of Earth's water is liquid, because water can be a couple of states of matter right here. However, some of Earth's water is solid, frozen in ice, caps, and other glaciers. Some of the Earth's water is an invisible gas. We call that as water vapor. Ooh, that's a terrible underline. Let's try that again a little better. Nah, we'll do. Okay, with water vapor. Okay, so in the atmosphere, altogether, all the water on Earth makes up a system called the hydrosphere. Dun dun dun, and all of its glory. Look at that. It's a lot of water. Okay. View from space right here. You see, we're getting a lot of ocean right here. Even the clouds, technically water. Okay. Now, Earth's hydrosphere contains salt water, which we learned in the last unit. Salt water is water that has salt in it. Mind blown, I know. So we're going to be right here. All the surface ocean water on Earth is interconnected and forms into one giant world ocean, but we just call them a couple oceans. We have certain regions that we call them. The largest ocean region is the Pacific Ocean. It covers approximately 1/3 of the Earth's surface. This is where the Earth's ocean is the deepest. The average depth of the Pacific Ocean is about 13,000 feet, 4,000 meters. At its deepest point in far western area, the ocean floor is about 36,000 feet below the surface. 7 miles. That's a lot. Okay. I believe we call this the Challenger Deep because it's very deep, it's unexplored. Okay. Now we have a couple illustrations here of the regions. We have the Atlantic, Arctic, and you notice the arrows right here, Pacific, Southern, Indian, and back to Pacific right here. They connect because the world is round. Okay, in case you didn't know that there's not another ocean called Pacific. There's only one. Don't be that person that's weird and thinks there's more than one. Okay, so sometimes we also call them seas or gulfs. Larger land masses, we call them on there. So be careful on the formality of it. The straits, all that. Okay, oceans, seas, and gulfs. Something that they all have in common is they all contain salt water. Okay, we had freshwater, brackish water, and salt water. Salt water we're talking about right now. Salt water is simply water that contains salt. Most of the salt, the chemical sodium chloride, is the same as table salt. Weird. Okay, some bodies of water are saltier than others. The salt that comes from rocks on Earth's land surfaces, it is picked up by streams and rivers as they flow toward the ocean. As water evaporates, note the water, the salt is left behind because salt cannot be evaporated. It stays and turns into a little chunky form. Okay. Over very long periods of time, this process has made this action very salty. Okay. So, this is another picture of some water right here. We have the Gulf of Mexico, Caribbean Sea, Caribbean, whatever. Okay, Straits of Florida and the Atlantic Ocean. I know it looks like one big giant form right here, but depending on the region, not part of the Atlantic Ocean, it's got all these little minor parts right here, all connected. Okay. Now, we're talking about the freshwater right here. Now, freshwater is usually the one that we like to drink. Oceans are only part of the hydrosphere. Water also can lives in, or water also occurs in streams, rivers, ponds, and lakes. These bodies of water lie on Earth's surface. There is also water beneath the surface between the rocky material. We have what's called groundwater. Places where water collects into all states is called reservoirs. Right here, we got a little vocab right here. Groundwater, water stored in the spaces between materials, reservoir where it collects, and fresh water coming down right here. Earth's main water reservoir is the ocean, but most of Earth's inland water reservoirs contain fresh water. That has low amount of salt in it. It's good to drink. It's not going to dehydrate you while you drink it. Rivers, streams, and wetlands are all products and contains fresh water. Okay. Now be careful in the transition stage where you got from fresh water to salt, that little transition part, that brackish part is what we talked about last time. Some groundwater and water in lakes are salt water instead of fresh water. The Great Salt Lake in Utah is one example. It formed when water carrying salt from rocks flowed into the lake. The lake has nowhere to flow out of. When water in the lake evaporates, weird, salt is left behind because salt cannot evaporate with the water. The salt's accumulated, making it extremely very salty. Okay. I did like this picture on here when I looked at the color of it. See all that purple right there? Kind of, or not purple, pinkish right there. Part of the Great Salt Lake is this pinkish color. Concentration of salt in this Great Lake is much higher than found in the world's oceans. So there's just more salt in this part. It's not as spread out in the oceans. Very cool colors. Okay. Now, on this portion right here, some of the fresh water on Earth is liquid, but can also be found frozen in glaciers. We talk about the ice caps in the North and South Poles being extremely right there. Okay. Fresh water from rivers flows into larger bodies of waters. Rivers flows into lakes, oceans, gulfs, and seas, where ocean becomes freshwater streams again. Then the water becomes brackish. Ah, see, I knew it. Solid. Okay. Brackish water has more salt than fresh water. Okay. So this is where we talked about the transition right here on the Mississippi River going into the Gulf of Mexico. Okay. So that transition stage. Okay. All right. A couple things we kind of hit on. I'm not going to spend too much time, but physical properties of water. We know water can be found as a solid, liquid, or a gas when we talk about the water cycle. Okay. A couple things to remember that we've done is water boils at 212 degrees Fahrenheit. Also, if you're doing a Celsius scale, which is nice to 100, okay, it freezes at 32 degrees Fahrenheit and Celsius, zero Celsius. Go with it, okay? Water evaporates or changes to a gas. The water vapor, notice evaporates. The word vapor is in there. They were thinking about you guys, okay? Vapor, okay? But it can evaporate at lower temperatures when heat energy is present. Water can evaporate even when it's frozen. That's very possible, going straight from a solid to a gas. Cool. Okay, talking about condensation when it occurs when water changes from a gas back to a liquid. We talked about this when we have the ice water on a warm day. All the water vapor that's floating around the gas gets onto the gas and glass, that was weird on there, but it's close to it and eventually starts turning from that water vapor stage to a liquid stage. That's how the water, it feels like it ends up on the outside of the glass, but that's just the water that's present around the glass. Okay. All right. Booming. Very cold right here. Like it. Water vapor, as gas right here, invisible. Oh gosh, look at that one. Okay. If we notice right here, this is going straight. There we can see the gas portion right there going from that solid liquid to gas. Okay. That's a terrible drawing. Don't judge me. Okay. Moving on. Now, the atmosphere is one thing we have to remember that does have water vapor into it because water will evaporate and it goes to the sky. Okay. Clouds are tightly packed droplets of liquid water. Eventually, these droplets want to fall back to Earth, known as precipitation. You know, when they start to get darker, heavier, and grayer, that means there's more and more water built up into it. okay? But it can happen with lighter color clouds, obviously, but it's really big water when it's turned a different color. That's just thicker, okay? So, very nice right there. Okay, going down. We have talked a little bit about the water cycle, okay? The hydrosphere is constantly moving and changing. Evaporation, wind, and precipitation move water from one water reservoir to another. Gravity also pulls it down. Weird, water falling from the sky. Okay. Dynamic movement of water below and above the Earth's surface is called the water cycle. As water moves, the hydrosphere interacts with Earth's land, air, and living things. In addition, changing position of water in the water cycle, constantly changing states. I really just wanted to read that word for word so I can kind of nail in the information that it's an important topic we need to know. Okay. So always constantly changing, always constantly doing it. Okay. It's just one big circle. Words to know dynamic means constantly changing. Okay. Ooh, Greek and Latin. Dynamic, dynamikos. Means powerful. Very cool. Okay. If I butchered that, go with it. It's fine. All right. Main important thing that goes with the water cycle, which gets overlooked, is the sun. Okay. Without that sun being present, that water cannot evaporate. Can't do it then. No clouds, so no precipitation. It'll just be constantly on the ground. Okay. That's really important for it to evaporate because it kind of cleans itself, gets the salt out of there. Okay. So, boom, shakalaka. Okay. So, oh, I don't know what I just pushed. Did something. Oh, I refreshed it. Good. Kind of done on here anyway. Okay, I'm going to stop my share. All right, guys. So I hope that kind of helped you out for chapter 1. Yeah, I'm going to post up the chapter as soon as the internet decides to work a little bit. And you can follow along if you want to, make some notes, or you can just watch it at your leisure. But do remember those things I started up. Those things might be good for later on. Okay. All right, guys. You guys have a fantastic day, and I will see you later. We're out.